It's conceivable that the universe is boundless in size. What we call the observable universe is simply the portion we can see, limited by the time light has had to travel since the Big Bang. There could be vast regions beyond our view that we will never be able to detect. While it's possible the universe is infinite, the question remains, is there anything beyond it? Most scientists are skeptical of this idea. If the universe is truly infinite, there would be no outside. It would simply continue without end. Even if the universe is finite, it may not make sense to speak of anything beyond it, as beyond implies something outside of space itself, which is a property of the universe. Thus, the idea of something outside the universe may not have any physical meaning. Just as the origin of the universe is a major area of study, so too is its ultimate fate. Current estimates suggest the universe will continue expanding indefinitely, driven by a mysterious force known as dark energy. This discovery overturned earlier theories. Scientists once thought that gravity would eventually slow expansion, possibly even reversing it, leading to a big crunch. However, dark energy appears to be accelerating the universe's expansion, and if this trend continues, galaxies will drift farther and farther apart. In this big freeze or heat death scenario, stars will burn out, galaxies will become isolated, and matter will eventually decay, leaving a cold, dark, empty universe. The story of the universe, from the Big Bang to its possible end, is one of the most profound and complex in science. Despite advances through the theory of inflation and studies of the cosmic microwave background, many fundamental questions remain. What triggered inflation? What lies beyond the observable universe? Does a multiverse exist? And if so, how many universes are there? As researchers continue to study the cosmos with advanced technology and new theories unifying quantum mechanics and general relativity, we edge closer to answering these mysteries. The quest to understand the universe is ongoing, and each discovery brings us nearer to solving the deep questions of our existence. Exploring the universe's origins and structure isn't just a scientific pursuit. It also prompts philosophical reflection on existence, reality, and humanity's place in the cosmos. A key area of cosmology is understanding dark matter, believed to make up about 27% of the universe's mass energy content. Unlike ordinary matter, dark matter doesn't emit, absorb, or reflect light, making it invisible. Its presence is inferred through its gravitational effects. Understanding dark matter is crucial for explaining how galaxies and structures form and behave. Despite insights gained through observations and simulations, the true nature of dark matter remains elusive. Candidates like weakly interacting massive particles, WIMPs, axions, and other exotic particles have been proposed, but no direct detection has yet been made. Meanwhile, dark energy, accounting for around 68% of the universe's mass energy, remains another great mystery. Its discovery was unexpected and led to numerous theories, from Einstein's cosmological constant to dynamic fields like quintessence. Understanding dark energy is key to determining the universe's ultimate fate, and scientists continue to study whether its effects remain constant over time or change. Research into the large-scale structure of the universe has also revealed much. Observations of the cosmic web, a vast network of galaxies, clusters, and filaments, show how matter clumped together under gravity over billions of years. Supercomputer simulations help scientists model these formations and predict their evolution. Cosmology also intersects with astrobiology, as scientists seek to understand the conditions necessary for life beyond Earth. The search for exoplanets, planets orbiting stars outside our solar system, has exploded in recent years, with thousands discovered. Some of these lie in habitable zones where liquid water could exist, raising hopes of finding life elsewhere. Fundamental physics continues to play a crucial role in cosmology. The search for a unified theory that bridges general relativity and quantum mechanics drives much theoretical work. Hypotheses like string theory and loop quantum gravity aim to explain phenomena like black holes and the early universe. Advancements in technology, such as the James Webb Space Telescope, are revolutionizing our ability to observe the cosmos in unprecedented detail, revealing insights about distant galaxies and cosmic events. Each breakthrough observation moves us closer to unraveling the mysteries of the universe's formation, evolution, and fate. In sum, the study of the universe is a rich tapestry of scientific investigation and philosophical contemplation. From the fundamental forces shaping cosmic structures to the search for alien life, our exploration reflects humanity's enduring curiosity and deepening appreciation for the vast, intricate cosmos we inhabit. The image of Proxima B revealed by the James Webb Telescope is essentially the clearest ever, uncovering stunning bits of knowledge about a potentially habitable exoplanet. As we embark on a journey through space to discover Proxima B's secrets and determine whether it could be the next Earth, it compels us. We must take off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock. It's real. We are only 4.2 light-years away from Proxima B. This planet is full of wonders and mysteries. Is there another Earth out there with seas and life thriving on its surface? Wait a minute. There's more. Proxima Centauri B isn't alone in that system around the red dwarf star. Proxima Centauri C is its companion. Additionally, the star system holds numerous other mysteries. Maybe there's another companion that we haven't yet discovered. The secrets don't stop there. Proxima Centauri produces roughly the same amount of energy for its star as Earth does from the Sun. Could this truly mean that there's water on its surface and perhaps even life? As we explore beyond our own solar system, we encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless, as if they were space travelers. Some exoplanets even move around freely without being attached to any stars. Why is this image so groundbreaking? Among them all, Proxima Centauri B stands out as an especially striking and captivating planet, with a year that lasts only 11.2 Earth days and a distance from its star that is generally closer than Earth is to the Sun. Indeed, one side of the planet is constantly bathed in sunlight, while the opposite side remains in everlasting darkness. Now, let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Alpha Centauri A, and Alpha Centauri B. Together, these stars form the closest star system to our solar system. The two stars, Rigil Kentaurus and Alpha Centauri B, form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf, an M-type star found 0.21 light-years from the other two stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us. Proxima, in fact, means the closest star in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 1113, which is much fainter than the human eye's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri remains an intriguing star. In terms of energy production, red dwarfs like Proxima Centauri are among the most efficient. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone would be much closer to it than the Sun's, projected to be somewhere in the range of 0.23 to 0.54 AU, but it's not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star regularly, stronger than the radiation we get from our Sun. That's right. It is so extreme that nitrogen, oxygen, and even the tiniest hydrogen particles are stripped away. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Living things would be susceptible to harsh space weather, making life nearly impossible. So, while Proxima B might appear Earth-like on the surface, it is far from being able to support life. Scientists remain somewhat cautious, as many factors render it inhospitable. The quest to uncover the truth about Proxima B continues, and some objectives remain. One tool that has garnered the attention of astronomers is the James Webb Telescope. How did the James Webb Telescope capture the image? After years of anticipation, the telescope was finally launched late in 2018 and will help us determine if there is life on Proxima B. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to ensure the James Webb Telescope delivers accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was designed with infrared light detection in mind. It can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Similar to Venus, Proxima B may have extreme temperatures and a thick, significantly denser atmosphere than Earth's, rendering life impossible. There are obstacles in the way of deciphering Proxima B's mysteries. Even though the James Webb Telescope looks promising, there are other things to consider. With costs mounting, space scientists are feeling the pressure to find ways to observe planets like Proxima B. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. Implications for future space missions. Could we visit the exoplanet in the future if it were habitable? It's the closest exoplanet to us, which makes it so intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions. It is one of the most exciting endeavors in the field of space exploration as technology advances. However, it's no easy task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed. Solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And now for something even more awesome. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, like anything ambitious, there are limitations. For instance, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that's inhospitable. Furthermore, get this. If the emission reaches a brightness that is only 5% of the daytime side, the James Webb Telescope is able to detect it. Although 5% may not seem like much, it is quite significant when dealing with a star that is typically less bright than our Sun. If Proxima B has advanced civilizations, they may use bright orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? Due to its proximity to Earth and potential for habitability, the discovery of Proxima B has captivated space enthusiasts and scientists alike. As one of the closest exoplanets to our solar system, it has become a focal point for astrobiological studies. Its position within the habitable zone of Proxima Centauri gives it the potential to host liquid water, a key ingredient for life. However, this potential is tempered by the extreme conditions described earlier.